Okay, so I want to go over this problem here where we have the p-value in between two values when we're doing the problem. Okay, so we have a random sample of 14 observations taken from a population that is normally distributed, produced a sample mean of 42.4 and a standard deviation of 8. Find the range for the p-value and the critical and observed values of t for each of the following tests using a significance level of 0.01. Okay, so use the t distribution, so it's t distribution, to find the range for the p-value. Okay, so we're going to worry about that last. We're going to go through and do the problem here. So you just want the critical value and the observed value for this information here. Don't think it's going to let me copy it onto my notes. Let me see here. Okay, well. Okay, so we get this information. We have a t-test. We have a sample size of 14. Okay, we have a sample mean, so an x-bar of 42.4. We have a sample standard deviation of 8. And we have a significance level of 0.01. The first test we're doing is given to us with a significance or a null of 46, alternative of less than 46. So it's left-tailed. Okay, so you've got H0 is that the mean is 46, and then H1 less than 46. Okay, so if I am drawing my curve here, we are left-tailed, significance 0.01. We want the t value that corresponds to this. So we have a degrees of freedom 13. So degrees of freedom 13, 0.01 in the area under the curve. So 2.650 is going to be that critical value. Okay, then you want the observed value. So you're going to do the t x bar minus the mean over the standard deviation of x bar. So remember, the standard deviation of x bar is the standard deviation of the sample over the square root of the sample size. So the standard deviation of the sample is 8 over the square root of 14. Is going to be 2.1381. Okay, then I have my x bar is 42.4 minus my mean 46 over 2.1381. So that's going to give me negative 1.6838. Right here. All right, so that is over here, not in our rejection region. Okay, this should be a negative 2.650. All right, so we go back to the problem. Okay, our critical value, negative 2.65, observed value, negative 1.684. So we got those. Now, the p-value for this. So here is what we are doing. You're finding where the p-value lies between. Okay, so meaning this. Find the p-value, so the probability or the area under this curve to the left. What is that area? Okay, this is a t distribution, so we're going to go TCDF. Lower limit, negative 99, because you're going to the left. Upper limit, negative 1.684, or 6, yeah, we'll do 684. Degrees of freedom, 14 minus 1, 13. Okay, that gives us a p-value of 0.058. The problem is not asking for the exact p-value, it's asking what it lies between. It lies between 0.05 and 0.1. Okay, so if you look at this chart here, what does it lie between? It lies between these two values here. So it's always going to be values that are next to each other based on what it is. Okay, so that's what it's asking for the between values. So it's 0.058, it's between 0.05 and 0.1. Okay, now if we look at the second one, this is a two-tailed test. All right, so the critical values are going to be different. The observed value is still the same when I do the test. Okay, the critical values are different because you're going to take the 0.01, you're going to divide it by 2. So you're going to do 0.005 on either side of the t-distribution. So if I pull up the t-distribution, 0.005 with a degrees of freedom 13 is 3.012. So that's where that critical value comes from. The p-value is the same. It's still 0.058, but because it is two-tailed, you're going to take that p-value 0.058 and multiply it by 2. And that gives you 0.116. So the two values that 0.116 fall between are 0.10 and 0.20. How do I know it's not 0.10 and 0.15? That one is more just trial and error, but when you get to above 0.10, you would go to 0.20. The smaller you get, the smaller the gaps are. But that's how you do where the p-value lies between. So if it's two-tailed, you have to multiply that p-value by 2. If it's one-tailed, it's just the p-value that you get.